Welcome everyone to Learning with Rev. Today we are going to be visualizing convolutions in this little Excel spreadsheet that I made up. On the left here we have our original image is what I'm going to call it. All the blacks are zeros and 1 is the maximum value in this image or in this array. And this one here, the max is 2, 4, goes on and on. So what is a convolution? A convolution is a dot product between two matrices. So in this video, we are going to be going over two-dimensional convolutions. So right here, we have our stride, 2 by 2. Stride can be 3 by 3, 4 by 4, 4 by 3, 2 by 4, whatever you want. But just for ease, we are going to do square strides. And this here is our kernel. So our stride is 2 by 2, and this here is called the kernel. In a convolution, we are taking a dot product of this right here and a 2 by 2 region of our image. And the kernel will move over that period. So if we just kind of visualize it, I'm not going to drop it here, but it's going to go there and calculate, there and calculate, there and calculate. And what we're doing is we're taking the dot product between this and whatever square it's over. For example, this top left solution here is the sum of the product between the first 4 and this. And the next one over is jump over the first row, this 4, and then this again. So if we convolve 5 here with 1, 1, 0, 0, we get this. In this case, this kernel is actually a feature extractor for horizontal lines. So if it was 1 and 1, it would be vertical lines, horizontal, this way, horizontal lines. As we can see, our vertical lines have gotten thinner and they're less pronounced, but our horizontal lines are actually more pronounced than they were before. If we scroll down here to the 3 by 3 stride, horizontal again, our feature extraction on the horizontal areas are really popping out now, and the verticals are kind of fading away. And again, in the 4 by 4, we do the same thing. So the purpose of a convolution is to extract these features. If your convolution is too big, you're really going to blur out your image, even though it might cause some features to increase, to really show themselves. So you have to find that balance between the stride size and how many features you want to really, and how much like pixelation do you want in the end. So again, we're going to convolve now this image with this 2 by 2 stride. Again, it is the horizontal lines are very much increasing and the vertical lines are fading away. If perhaps we change this to, I should not have deleted that one. If we change it to horizontal here, we can see it has done one where it kind of captured the horizontal segments, and now it's capturing the vertical segments of this. And we get essentially a one pixel thick bright spot. Initially it was about 2 pixels thick. This one here, it varied it a little bit, and it makes it 1 right here. So based off the size of your convolution and how many you have, or the size of the stride, how many convolutions you have, you'll get different features pulled out of it. In this case, it's really blurring out this 4 by 4 stride. However, if we use things like max pooling and batch normalization, that should allow these features to extract a little easier. And we'll be going over those in our next videos. If you learned something, or if you have any questions, please put them in the comment section. If you like this video, do share it, do give it a thumbs up, and I'll see you next time.